Good day, folks. Today we'll be discussing these pressure switch rationality codes from a 62T transmission. These particular codes have a long history of misdiagnosis, and the peeps they treat these rationality codes just similar to that of a solenoid circuit code and would go out and change a solenoid, or hoping that it's going to fix it. Now, the solenoid circuit codes are similar to that of any other generic transmission, and if you get one of these codes like a 750 or 60, it would mean that one of the solenoid circuits are gone bad. But if you get a rationality code, it does not mean that there is a problem with the solenoid circuit that the PCM is detecting. It's something else. So to figure out what it is, we'll have to dig a bit deeper into how the PCM controls the hydraulic pressure in a transmission, and we'll go from there on and see what these rationality codes are. So this is a generic diagram where we have a PCM, we have a solenoid over here, we have a pressure switch over here, and there's a clutch pack over here. So the PCM energizes the coil for the solenoid, which in turn lifts the cylinder, and the fluid pressure that exists around the solenoid will seep into the hydraulic circuit and will uh, change the state of the clutch pack on the right. Now, the PCM needs a feedback mechanism to tell it that whether whatever the command it just issued actually worked or not. So this feedback mechanism comes from this pressure switch. So pressure switch is directly attached to the hydraulic circuit. It has a gallery of hydraulic fluid that pressurizes, that actually presses or depresses the pressure switch, which in turn creates a ground from an active voltage that the PCM is able to see on this pressure switch one line. So usually it sees 12 volt because it goes over there. There's a resistor in between, and it sees around 11.5 volts to 12 volts in here. But if it goes to ground, then it will know that yes, the pressure is now actuated, and whatever the command that was issued here, it's now able to see over here. And whenever it does not seize that for example, if it energizes the solenoid, and it should have there should be some pressure in here, but for some reason it does not see any drop in voltage on this pressure switch one, it will trigger a rationality DTC, one of these DTCs. There are about five pressure switches in the 62T solenoid pack, which work independently of each other, and based on the issues, various issues which can happen, the PCM or these pressure switches can go wrong. And usually these are the culprits. These are the major and main culprits of these particular DTCs, the rationality DTCs. So let's see. If you see that now, apart from these pressure switches, there are a few other problems that can happen, and then that can cause a problem for these rationality DTCs. The first one is a blocked solenoid. So if the solenoid is blocked, then obviously there will be no pressure in the hydraulic circuit. The pressure switch will not change its state, and the PCM will figure out that there is some problem because it will not see anything from the pressure switch. There may be some other associated DTCs, but for sure it will throw out one of the rationality DTCs. Similarly, the block path, if the solenoid is not jammed, but probably the gallery is jammed here, or probably some other thing that is inhibiting the pressure to reach to the pressure switch is blocked, then again that would be result in a similar DTCs. If there's an internal transmission problem, which is in the clutch pack, if the pressure that goes to the clutch leaks out entirely, if the one of those bonded pistons and there is broken, or it's leaking fluid everywhere, then the clutch won't work, and the hydraulic circuit it won't pressurize, and it will prevent it from pressurizing the pressure switch. Similarly, a bad PCM can be a problem where this, even though it is getting some voltage over here, it's not recognizing it. Maybe some internal issues. Uh, the major issue which we discussed already, that is the pressure switch itself, it can go bad, and this is the major reason. And in fact, every time I saw this issue with the rationality DTCs, it was the pressure switch. And the last possible problem can be a failed solenoid back housing, because all these pressure switches, they reside inside the solenoid pack housing, which I'll show you in a while. It looks like this. So if any of these fails, if the solenoid housing itself fails, then you lose the contacts, and this thing is going to fail. So these three parts, the ball block solenoids, pressure switch, bed pressure switch, and the failed solenoid housing, you can check it and you can rebuild it without any issues, and it's really simple. So first of all, let's see how a pressure switch works. So a pressure switch is comprised of a metal cape, uh, a small rubber disc or washer. It's not a washer, it's not a disc. You can call it a sleeve or a piston, and then a brass contact, a spring, and then a contact point inside the housing. Now this point is a circular ring that is integrated inside the black solenoid pack housing. What it does is that this spring actually sits inside this spring pocket or the brass contact, and this brass contact resides on top of this flat side of the the rubber sleeve, which goes into the cap. So you can see that the cap there at the bottom there are holes, so the fluid actually leaks into. So if you go back to this original concept over here, this one, so when the pressure comes from the bottom, it actually seeps into the base of this cap and pushes this rubber piston upwards, on top of which this cross contact resides. Now, usually this spring is there to ensure that this particular setup of the pressure switch is always open, which means that this brass contact does not touch the contact point in the assembly housing, and this spring is actually there to keep them separate, which will make sure that the PCM does not read any contact between these 2 points. So this point is actually directly connected to the PCM, and this spring provides a ground directly to this particular brass contact. So this is ground and this is connected to the PCM. So when the fluid pushes this thing up and this brass contact contacts the top contact, the PCM will see a ground because the spring is grounded. The bottom, now how the spring is grounded, the top of the spring is connected to a flat metal plate, which I'll show you later, which is grounded, and based on this it gets a ground from there and connects it to here. So there can be a few things wrong in this particular setup which can cause the pressure ring to fail, and usually the most common culprit is contamination. So the lower side of this contact, the upper sides of this brass contact, and the bottom of this brass contact, if all of them are contaminated, then the contacts from string, and similarly the top and bottom of the springs, if all of them are contaminated, they will not make a good electrical contact from here to here to here, from here to here. So if you can just disassemble this power switch and just clean it, you can be rest assured that your transmission will start working like new. And this contamination usually comes from the torque clutch converter, which usually wears off after 100,000 miles or something, sometime before that. And that's why exactly regular maintenance of transmission is required. You have to change the fluid regularly because this particular transmissions provide a bit of muck in there. The clutch, the transmission, the torque converter clutch, it wears off quickly. So let's have a better look at it. So this is the solenoid housing, as I told you. So this is the metallic housing under which the springs reside. In fact, the switch resides in these pockets. 1, 2, 3, 4, 5. This is where the springs reside, and they get a ground from this particular plate. So if you open this, what you'll see is that right underneath it, you'll see these holes. 1, 2, 3, 4. I can't see the fifth one from here. But anyways, you can see them clearly on here. If you flip it, you'll see this particular end, and you'll see those contact points. So all of them with those small ridges and points inside the circles. These are the parts of those pressure switches, and these metallic parts are actually the contacts that I discussed earlier. These contact point inside the black house, and the same thing here, the same black ring here. So these rings are embedded into this black housing. So you can see them. So these are 5 of those on. We have those 5 pressure switches, and that is exactly why we have these 5 rationality codes that I showed you at the beginning, these 5 of them. And all of them you can actually explicitly bring them to where exactly is the problem. For example, if you have a 083B LC pressure switch rationality, so you are looking at the LC pressure switch, which means that which is here, this one. So this is the reason you are getting the problem. So you clean it, you are good to go. So first of all, you need to make sure that you have to really properly clean them. Don't use too aggressive chemicals, just a cotton bud or something, and just clean off the muck, and that's it, you're good to go. Secondly, if you look at the back side of this, which is actually the front side, you'll see these 300 ohm resistors. These resistors provide a reference. Over here I've shown it. Where is it? Yeah, here. So this is a 3 ohm resistor. So usually whatever the voltage supply is, the PCM will see this resistor, 300 ohm resistors across the supply. So the voltage that the PCM will eventually see, usually in an open pressure switch, will be slightly lower than that of the 12 volts. So you can, while you are here and you are looking and doing all these things, you can probably check the resistances of all these three resistors. And if one of them is bad, you can probably change it. So this is really a simple solenoid assembly pack, and I think that it's the first time I did it, I finished the complete job in about 40 minutes or so. So nothing there that can intimidate you from fixing it. Similarly, I pasted this table for testing if you want to test it. So it says that the positive meter lead on 10, which means that if you take out this particular connector, you find out pin number 10, which is 8, 9, 10, put the positive lead over here and negative lead on different pins, and it tells you that where does it go, if it goes to a resistor or a solenoid. So all the red ones are for the rationalities, and these are the pressure switches that you can test, and you should see 300 ohm in there. So it says 1, 2, 3, 4, 5, 6. So there should be six, sorry, 1, 2, 3, 4, 5, 5 rationality switches. So it means that there should be 5 300 ohm resistances, but I was only able to figure out 3 of them. Couldn't find the other 2, or maybe they are being used for 2 of them. I don't know. And yeah, so just make sure that if you want to measure the resistance, so once you have opened it like this, you can measure these the pressure switch resistances, but you cannot measure the solenoid ones. So you may, if you want to do the solenoid as well, make sure that your pack is completely assembled in this stage, and only after that you can use it, measure the solenoid resistances. These are the standard resistances that you should get from a completely packed solenoid assembly. So in the end, I have this figure of the solenoid. So once you remove this top black housing, this is what you will get. And there are usually some rubber sleeves over here, so just make sure you don't lose them. And apart from that, I think these 4 of these, the white ones, the top, it does not have any paint marking. I think these are normally closed, and these 2 are normally open, I believe. So just make sure don't mix them up. Also, their position and inclination on angle of these connectors is critical. Just don't use this photo as a reference. These 2 pins are slightly slanted. They are usually totally flat. So as soon as you disassemble your pack, just take a photo of it as a reference, that when you are putting this black assembly on top of it again, you don't mess it up, because yeah, you don't want to break the pins of these solenoids. Alright guys, so this is a valve body along with the solenoid pack that I have out of a 62T transmission. So the first thing that I want to discuss is that if you just want to go through the solenoids, except this one, and all the pressure switches, you don't have to remove the whole valve body along with this solenoid pack out of the transmission. All you have to do is inside the car, while still it is inside mounted onto the transmission, all you need to do is hold on, remove these 5 bolts. 1 2 3 4 5 1 2 3 4 5 6 bolts, and this plate will come off and start being accessible. So right off the bat, what we can see here is that it has 6 bolts on this plate, and it is spring loaded, which means that if you remove this plate, there are springs behind it, it's trying to push it forward. These springs are located here: 1 2 3 4 5, and all these springs, as we discussed, belong to those pressure contact switches or clapper valves. Also, these bulges over here, they are the pins. These are the pins for the solenoids that are behind it. So when you are trying to remove it, immediately 2 things can fall off, because it is usually, in fact, it is always mounted vertically, which means that the plate is vertical. You remove it, some things can fall off, and those things are the springs which are behind it, and the dowels in which these bolts go through onto the valve body. So just try to be cautious and be ready for those falling springs and dowels. So let's see if we can remove it. I've actually cleared it already. I was just ready to go in, but just to show you guys how it works. So I'll remove these. Just put some pressure on it because it's spring loaded. You don't want to put all the load on a few or one spring. So now keep pressure on it. Remove these bolts and set them aside. Now carefully remove it, otherwise the springs will jump out. So this is the back side of this body, and it has some housings for those things that are underneath it. So carefully remove these 5 springs. 1 2 3 4 and 5. So these dowels, 1 2 3 4 5 6, for the 6 screws or bolts, they are not gonna come off easily. Sometimes they jump out, sometimes they don't. So now it is the second stage where you have to remove this thing. So the bolts are already removed. All you need to do is, because you can see here, this particular solenoid, the pins of the solenoid are actually they went into this black solenoid assembly housing. Same goes for this. There are 2 pins over here and here, and they are holding it down. So you need to carefully pry it out just to make sure that all those wires are disconnected. Slowly pry it out cautiously. It's not gonna take much time. It's loose already. And before you take it out, just be ready for another falling thing. Either these dowels, or there will be some rubber seals on top of these solenoids that can fall off. So be ready to catch them. So carefully remove it. So once it is removed, yes, one of it fell out here. So yeah, they tend to come out. 2 and more coming out. This thing, I'll just take them one by one instead of losing them. 3, come on, June. Okay, I think now 1, this one is still in there. So it's better to take them out before losing count of them or wondering where they go. Okay, so 1 2 3 4 5 6, now they're all out. So let's just flip it back and let me show you those pressure switches. So these are the pressure switches: 1 2 3 4 5s. These are the things, these are the reasons we are into we are actually disassembling this housing. So I'll get back to them in a while. So behind them, these were the spacers, or the plastic the rubber rings that I was talking about. Just make sure they don't fall off. 1 2 3 4 5 6, they should be in there. Also keep mind of the position of these 2 painted ones, because if you're going to remove them, you might want to put them back in exactly the same position. While we are here, we can also go and remove them and clean them off and put them back. So usually you need some kind of a tool to
pry them out. All of them have small holes on the sides, so you can just start by gently prying them out. I usually use the hole to, and use such a pick kind of thing to just pull them out, and slowly, be carefully. I've already cleaned them. I just want to show you that it's not too difficult to take them out. Oh man. Just trying to be careful here. Huh. One of my dolls is over here. 1, 2, 3, 4, 5, 6. Okay. Using two hands is really easy. And while you're pushing it out, just try to move it and wiggle it. It'll come out a lot easier. Oh, here it is. So I already cleaned it, so I'm just gonna put it back. I've already cleaned all these solenoids. So once you put it back, just make sure that you align it to the same position in which you took it off. So these ones are fairly easy to put them back because they're on a straight line. But these two are at a different angle. This one is at a slightly more inclined level than this one. So just be careful about how you position them. So 1, 2, 3, 4, 5, 6. These 6 solenoids plus this one. You can take them out, clean them, measure their resistance, and then put them back. To take this one out, you'll have to take out the whole valve body, remove this whole setup, and at the back there are these 2 pins which are holding it down. You have to push these pins out, and only after that it will come out. So I usually never have any problem with this one, and the reason I'm working with transmission, it does not have anything to do with whatever I'm doing right now. So I'll just ignore it because it was working fine already. So these 2 dowels, they are permanent mounted onto this housing. You never need to take them off. Apart from that, let's now go back to the housing that we just removed. Okay. So these are the pressure switches in all their magnificence. So you can just, the easiest way to take them out is usually from the other end. They are pretty tight, and they are not too tight, but just snugged in. So you can see that the brass contact you can see from here. So just take any pin and just slightly push it out, and you'll have it. There you go. Sometimes they fall off, so be careful, because this one of them is already loose, I can see. So yeah, you don't want to lose them. So now let's have a look at these valves. So this is the top brass contact. Okay, and there you can see the rubber sleeve along with the cap. So the cap has those small holes at the bottom, which actually allows the hydraulic fluid to come in and push this sleeve up. This rubber sleeve, whatever you call it, I don't know. Let's see if I can blow it out. I don't want to lose it. Let's see. Oh, here it is. So now we have the whole switch out. So things that can go wrong, these holes, if they are obstructed, obviously the fluid will not come in and will not push this thing. This thing, if broken, which is not in my case, will let the fluid come directly to the brass contact without building any pressure on it. So I've looked at these 2 things, they are good to go. So when you're putting it back, just make sure that the cup side of this rubber ring or seat goes downwards. It acts like a piston to move this thing up, and then you can just simply put this one on top of it. So when you're looking at the brass contact, just make sure that there is no dirt at the back. I can see some dirt because I still have to clean it. I didn't clean them. I'll just clean them and just put them back. So once you are sure that's all good, you can just take the housing and gently put it back in. It's not going to fall once it is in there. Or you can just take this thing first. You can see in the housing, these are the contacts that I was talking about. At the back is a contact with those ridges in there. So yeah, just the one with the ridges. So you can see the contact, it actually connects here. So there shouldn't be any dirt on that contact and this face of the brass contact. So just put it in and then just put the cap along with the sleeve on top of it. So yeah, your pressure switch is good now. So you have to clean all of these pressure switches to make sure that you're doing good. So once you're putting it back, just keep in mind that if you forgot the location of the dowels and the springs, so the springs goes in those pressure switches, which have those small ridges in here, in all of them, and there are 5 in total. While the dowels, they just go plain, do not have any ridges. So these ridges actually are really, also pay close attention to these ridges, because if any of those are broken, it means that your spring is directly in contact with the contact which gives signal to the PCM, so it will always be grounded. So the power supply will always be grounded, and PCM will not see any supply on those pins. So in mine case, all of them are good, no issues over here. So yeah, that's pretty much it. So there are a few things that I forgot to show you. First of all, these 3 resistors, all of them are 300 ohms. These are the pressure switch resistances, and this is what PCM sees if the switch is not closed. Let's see, 300 ohm switch. So all 3 of them are 300. There are 5 switches. There should be 5 of these resistances, but I can only see 3. There's another one small here. I think it's a diode. Anyways, one more thing is that how to identify the pinouts for this. So if you look at it, it has 3 pins over here and it has 3 pins over here. So where do you start the counting? So just to keep in mind that you start the counting from the side which has one of the pin slightly at lower position. For example, this one, the first 2 pins, they are at the same level. The third pin is slightly under the and lower than these first 2 pins. So this is 1, 2, 3. So I'll just go through and show you a couple of measurements on these pressure switches. Now note that these are not connected. There is just the contact. So the way it works is that the power supply goes from pin number 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it goes to the pressure switches, which are currently not connected. So it should show around 300 ohms. So the pressure switch that we have is number 11, 14, 15, 16. So 10, right next to 10 is number 11. And there you go, 300 ohms. Similarly, we have 14, 13, 14, 10, 11, 12, 13, 14, sorry. 300. Then we have 15, 16, 15, 300, 16, 300, then 18, 17, and 18. All 300. So yeah, just keep this in mind. Nothing is connected. You should be getting 300 ohms. This is because this is what the PCM sees when these switches are not working. So what does the PCM see when they're working? Well, the PCM does not see anything. The PCM sees a ground. So that's how the PCM knows that the switches are functional. 2 values, either something around 11.5 because it has a 3 ohm resistance, or a ground. So yeah, that's it.